Hello everyone and welcome back. So now we're just going to be going over circles and triangles in the construction part of paper 2. So what we're first going to look at is we're just going to look at how we construct perpendicular bisectors and angle bisectors. Really simple, but they are important to know and to show your workings when we're doing these. So the first thing we're going to do is whenever we're bisecting a line, it's really straightforward. So let's just say we have this line here. It doesn't really matter. So I'll try and go back to pencil. We'll say A and B. So to bisect this line, what we want to do is you want to go get our compass and measure any point that's greater than halfway between A and B. Because if you look, if it's less than B and I draw a circle, or it's less than halfway between the two. So we put on A, now we put on B. They don't interlink, but we want them to intersect each other. So to do that, they'll have to be greater than halfway. So between half and full thing, so it really doesn't matter just as long as it's more than half and less than the total number. And we have this point here. We'll call it C. Now, what I really should have done is I just should have continued the circle for down here. Oh, and that happens to me all the time. I just get squiggly lines like that because I find it hard to hold the compass. So there's B, here's D, and if we join these up with a pencil or a pen or whatever you want, draw that line, then 90 degrees here, 90 degrees here, and that is known as the perpendicular bisector. Now, so the other thing we need to know is the bisector of an angle. So let's just say we have any angle here. So we'll just say there, there, really doesn't matter. So what we want to do is we want to just get our compass and measure a small enough circle or a small enough arc that hits both lines. So we'll just call this line A. So line A and line B intersect to make this angle here. We'll call it alpha. Okay? Doesn't really matter what you call it. Then what you need to do is you need to get your compass and again measure something that's relatively, not too long, not too short. Make an arc. So you want to put your compass here and you want to put your compass here. So they intersect at this point here, C. Now we get out our pencil or whatever we do we want to draw the line with and make sure we go through the center, so C. And that line there is our bisector of an angle. So this is bisector of an angle. And it's as simple as that. So I probably should have shown you that before the previous video, but it's here now and you know how to do the perpendicular bisector and the bisector of an angle. It shouldn't be too difficult to understand, but I can see that if people haven't done it, so I did Tech Graph for Junior Cert, so I knew kind of how to work with them. But I can see that if you didn't, or you don't really have that kind of way of thinking, it might be a bit tricky for you. Okay, so what we're going to do now is we're going to look at how to construct the circumcircle of a given triangle. So as you can see, or as you will see, sorry, the circumcircle of a triangle is the circle that goes through each of the, let's say, tips of the triangle, or each points of the triangle, known as the vertices. And then what you see is we also have this incircle. So the incircle is the circle inside the triangle. The first thing we want to do is just create the triangle. Doesn't really matter how it looks, but we won't do it too big because I want to save a bit of space. So we'll go right in the center. So this doesn't look, it's obviously not a equilateral triangle. Doesn't even look like one. Well, but that doesn't matter. So let's say we have these points A, B, and C. Now what we're going to want to do is we want to construct the perpendicular bisector of any line. Okay, so I'm just going to pick AB because they come first alphabetically. So I want to join them. I want to do the perpendicular bisector. So it's going to have 2 points. They need to interlink. So put the compass on A and then put the compass on point B. So I can see that they intersect here and here. So I need to get the ruler out and just draw a nice small line, nothing too fancy, nice and light, through the point AB. Now you can see that for this example the line doesn't go straight through C, but that doesn't matter. Now the second thing you want to do is you want to construct the perpendicular bisector of, let's say, any other line. So we can pick BC or AC. So I'm just going to pick BC. So again, perpendicular bisector, as long as it's halfway between the lines, it doesn't matter. So it's halfway between BC or over halfway between BC. So there and there. We want this point here and this point here. We do the exact same thing. We draw a nice straight line through B and C, nice and light, like so. And where they intersect is our circumcenter. So what we want to do is we want to see where they intersect. So we can see that they intersect right about here. So I might just use a different pen. Use a black pen, like so. And we'll just call this O, because generally that's what we use for like the origin or the center of a circle. So what I need to do now is, if I do a radius of O to any of these lines, they should all touch, and they do. Now it's a small bit off on B, I can see, but it's basically good enough. And there we go. The compass slips a lot for me. I'm obviously not doing it very well. So there is the Incircle, or the circumcenter, and the circle. So here, what I can say is that O is the circumcenter, and the circle, so we're just going to give the circle K. So K is the circle, which we know the circle is called the circle. And think about it as like circumference, so all around the edge. So it touches each vertice, or each vertical, or each vertice of the triangle. So each pointy bit, A, B, and C. So as I said, C or B is slightly off, but that's just something I did wrong. We'll just kind of make it look like it does it properly. Yeah. Just like that. And of course, depending, so I did a big like dot for O, but the smaller that dot is, the more accurate they will intersect. So you'd be able to get a more pinpoint. I might be leaning slightly to the right or slightly to the left of the O, and that's why it won't intersect at B. But that's just for kind of presentation purposes. So next you want to do is you want to construct the incircle. So again, we just have any random triangle, but we might be given the triangle, we might have to create the triangle. It all depends on the question. So we'll just do a nice, so I'll just do a really strange circle now, a really strange triangle like this. So it's not like your normal equilateral, it doesn't even look a bit like one. It looks a small bit like a right angle triangle, but this is probably like 85 degrees. So the first thing you want to do is you want to construct the bisector of any of the, or the bisector of the angle of any of the angles. So I'm just going to, again, we'll just call it ABC. And just so you remember it, we don't do anything different, we're going to bisect the angle A, we'll just do it at A and then bisect it at B. So to do that, we need to do, so it's very small triangle. It would probably be bigger in the exam because obviously you'll have loads of pages to work with or loads of space to work with. So here is our bisector, like that. Okay, so we know that we have now bisected, which means we halved the angle B, A, and C. So now we're going to do the same with A, B, C. So we need this is very important. Just so, why we do that is we get two equal line lengths, basically. And then we set that as our mark. We'll just do, so you can adjust this. So this is a bit annoying because I can see it bisects, or it kind of goes through the other one. But there now I can see that we have this point here. So just to make it easy, we put the compass here, and we put the compass here, and we drew two arcs to get this. Okay. Then for B, we got these points here by just drawing a small arc, and then we just adjusted the compass to make sure that they'd intersect, and we got this point here. So what we now have is we have this line going like that. So we have the bisector of BAC here. We'll call this line D. And then we have the bisector of ABC, and we'll call this E. So what we're going to do is, so we had the circle and we used O for that. So because this is the incircle, we'll give it a nice easy name of I. So where do these two interlink? So we have E and B, or E and D, and it's somewhere like there. Okay. So what we're going to do now is we have to use kind of our rulers to now draw the perpendicular of I, so on the line A, B, because they're the two angles we chose. So kind of we're trying to restrict it to, basically we isolate C or we do nothing with C. So we now need to get the perpendicular bisector. So what we do is, in the last video, as we see, we get the straight line from A to B, get our set square or ruler or second ruler, whatever you want to look at it as, and without adjusting it, bring it down here, like so. So this is my A, B, C, D, E, we'll call it point F. The I is my incircle. So now what I should be able to do is the radius I to F should cut each of the parts of the triangle inside, because it's incircle, inside the triangle. So now, forgive me if it doesn't look fantastic. You can see it kind of gets a bit lost on, let's say, B and C. I'm not the best person in the world with a compass. But there you go, you can see that's starting to work now. And there'll always be a small bit of error. So let's say they mightn't be completely touching. So you can see that the first one I drew was slightly off, so I knew that that probably wasn't very acceptable. So I just adjusted a small bit to make sure that it fitted inside. And there you can see the incircle. So we're going to call this circle, let's say we have K up here, so we'll call it circle H. Okay. So now what we can say is that I is the incircle, or the in center, and then H is the circle, that's known as the in circle. Okay. So what we're now going to look at is we need to look at how to construct the centroid of a triangle. So to do that, we just have to do these steps as followed. So the two last constructions we need to know is how to construct the centroid of a triangle and how to construct the orthocenter of a triangle. So just a small bit of theory, the line segment that joins the two tips of a triangle to the midpoint of the opposite side is called a median. So you use all sides for this. So we'll construct that in a second. So how to construct the orthocenter? Well, the perpendicular line segment that draws from the tip of a triangle to the opposite side is called the altitude. And then the point of intersection of all the altitudes is called an orthocenter. So there's just 4 centers we basically learned. So there's no circles with this. This is just finding the points, basically. So the first thing we're going to do is just draw triangles. So generally you just do a triangle like this. Now you could always draw, technically, a triangle that doesn't look very nice. So let's say an obtuse one. But you might as well just keep it nice and simple. Keep kind of the angles all between like 30 and 70 degrees, do you know? So don't go mad, because we're used to that. And we want to kind of make it as easy as possible for us in the exam. So if you make the triangles we already know, then that's going to be okay. It makes it so much easier when you come to actually do the questions. So in this circle, what I want to do is I want to give them each of these vertex or the tips names. So we're going to call them A, B, C. So what we have to do, because we're doing the centroid, is we're going to have to get the perpendicular bisector of every single side. Or even if you just pick, let's say 2 for now. So when we're looking at the centroid of a triangle, what we're going to do is we have to find the midpoint of any 2 sides. So let's say the midpoint here and the midpoint here. And then we're going to have to draw a line from that midpoint to the opposite vertex or opposite point. So to do that, it's very simple. So again, all the skills we really need to know is how to bisect an angle and how to get the perpendicular bisector of another line. So we draw any line that's greater than a half. So we've been through this before. Give it a nice arc. And the same here. A nice arc. So you can see how easy it is for them to slip. Now I'm sure the point of my compass probably isn't very good because it's old and probably being used a good bit. So here we have our perpendicular bisector, not perpendicular bisector, or perpendicular bisector of A or BC, and we get the perpendicular bisector of AB. So I'm going to keep the same circumference because, or the same radius in the compass because I can see it's over half of AB. So here and here is where they cross, so I can now do a nice line like so. Okay, So what you need is you need two midpoints. So I could have gotten AC, but it was just, so mid, I'll just continue at point and midpoint. Now what you need to do is, I probably shouldn't have drawn such a dark line there, so I'm just going to rub it out enough that they can still see my workings, but it's not going to interfere with what I'm doing next. And what you're going to want to do is you're going to want to get wherever the midpoint is and connect it to your opposite vertex, so the opposite point. So I'm going to do just a dotted line for now. Okay, then get this midpoint and go to C as well. Okay, so that there where the two medians, so that's what they're called, medians, intersect is called the centroid, and we'll just give that the name G. Okay, so we'll say there's a few things we need to take down, so three things. So the first thing is that G is centroid, so the center centroid. Okay, so the line from A to the midpoint is known as a median. So just like we have in probability, the median is also a term we use in geometry. And the midpoint is gotten by perpendicular bisector. Perpendicular bisector. Okay, so that's really it. There's not too much to that one. That's all you need to do. Now I know that they all seem very similar, but I'm telling you, or trust me, that if you watch this video enough times, then you should be able to kind of see there's slight differences with everything you do, and it's really important to know these.